Thanks, Stefan, and good morning. As I said, my name's Steve Cockerell. I'm the Industry Marketing Director for Bentley. Back when I had a proper job, I was an engineer. Now I'm just a marketing guy, so I have some affinity with all of you in the room. My job today really is to give you an overview of our road and rail solutions and how they support the BIM processes that are becoming ever more prevalent, ever more important within our industry. But what I wanted to do was go back to one of these reports that Stefan referred to. Another one by McKinsey & Company that was issued in the middle of last year. And as you saw, we as an industry got a pretty bad school report, poor in fact. So McKinsey looked into this in a little bit more depth and surveyed around 2,000 companies globally and asked them where they were focusing their efforts to improve. And the three areas that they came back with was back office integration, so using the different data types that exist throughout your organization on finance and schedule and personnel and law and things like that. On digital collaboration, and Stefan's talked a lot already this morning about digital collaboration, and I'll talk some more about that in the context of road and rail in my presentation this morning. And also on-site execution. So automating that process and being able to use the models that you're generating in your applications directly in the field and have them control the machinery as opposed to requiring interaction from one of us. It also found that the reason we scored poorly was because of a mixture of things, really. We get very excited about new technology, I know I do, but it's sometimes difficult to introduce those into existing workflows, into projects. Sometimes it happens without the right training. And our expectations are perhaps higher than the reality that we witness. It might be a lack of commitment in terms of the team looking at it or financial. And so they came up with 4 steps, and I wanted to talk about those 4 steps because Stefan talked about digital transformation and we talk about digital advancement at Bentley. It doesn't happen by accident. Nothing happens without a plan or a strategy. And that's step 1, is have a plan, create an organization. It might not be a big organization. It might be a small task force within your organization or project that targets what you have today in terms of technology, where you want to be, what you aspire to achieve through the use of this new technology, and set timelines and goals for achieving that. Now, one organisation that was struggling with a mixture of challenges, and I'll just put them all on the screen there, is Oregon Department of Transportation. Now, as part of their legal requirements to the federal authorities in the state, they have to produce lots of reports on their infrastructure, their road infrastructure in this case. They had many, many different copies of the data spread throughout the state. They had lots of different systems that they were using to provide those reports, and they had lots of different workflows or processes. And they were struggling to get the right results. Sometimes it would take days, even weeks, to produce what should have been a really simple report. And what they did was come to Bentley, and we helped them create what they called a connected data environment for transportation. We removed all the duplication, we looked at all of the processes with them and worked on refining those so that they had one set of rules to follow, and it is delivering them already some very significant savings in terms of time, effort, and a reduction in risk. Step 2 is to turn projects into test labs. Try it, see how it works. If it fails, you've done it quickly, move on, learn from those lessons. But if it works, great, let's look at how we can develop it further and improve further. And an organisation that's doing just that is the Roads and Traffic Authority in Dubai. Now, the RTA is the owner of the Dubai Metro that you can see there on the screen. It's still the world's longest driverless metro. But they realized that they didn't have a single source of trusted information on that railway. They didn't have it throughout their design and construction phase, and they certainly didn't have it during operations. And that was a big issue for them. They wanted to use BIM and follow the UK government's BIM standards and processes to be able to hand over information from construction into operations so they could operate the asset more effectively. And they've got an exhibition at Expo 2020 happening very soon, where they're extending this metro out to the Expo site, which is by Dubai's new airport at Al Maktoum. The way they're doing that is through a connected data environment. And that enables them to work towards their vision. They have a very clear roadmap to the future, a strategy, if you like, for getting there, and timelines that they're setting. And within 3 years of implementing this CDE, this connected data environment, they anticipate quite significant savings in time reduction in time and effort during the delivery of projects, and that includes communication with their supply chain, but also quite significant amounts of savings in terms of material costs during operations and maintenance. And if you think about 80% of the cost of an asset is actually in its operations versus a very much smaller percentage to actually build it, if you consider the whole lifetime of the project or the asset, those numbers can be very significant. Stefan mentioned this, information or data is key. So let's let it lead the way. Let's make that information do all that it can for you. And moving back to my home country in the UK, as you might be able to tell from my accent, is Network Rail. Network Rail are the UK rail operator and owner. And they were struggling to make the right decisions on how to maintain what was and is an aging asset. They had lots of different people throughout the country working on the versions of the data that they had, and they were struggling to do, in their words, the right work at the right time in the right place on their network. And that's really the key. In order to optimize the budget that they had available, they needed to know where to do the work and how quickly they needed to do it to optimize the use of their budget. And they're working, again, with a connected data environment and asset-wise. Stefan talked about project-wise. The other part of our connected data environment is asset-wise, and that looks after the performance and the reliability of your assets in the future. And again, we're talking about big numbers. They're able to have the information they need wherever it is, either in the office or in the field. And in fact, the mobile technology that you see on screen there with our AssetWise product sat on an iPad was the tipping point in adopting this technology and it becoming very successful for them. And that saving of £125 million was over a 5-year period, and that sum was removed from their operating budget, from their maintenance budget, so it had to work, and that was driven out of a pilot project that they ran. So last one is increase investment. And I always get a little bit embarrassed standing up in front of a group of people like yourselves and say you need to spend more money on software, working for a software company. But actually, McKinsey say that you really do need to increase investment, and not just in terms of buying software from Bentley, for example, but in partnering with different organizations to achieve the outcomes that you seek. Now, one organization that is working with us and with Microsoft, in fact, is Mass Rapid Transit Corporation in Malaysia, in Kuala Lumpur. Again, you see that BIM workflow that they need to follow. The processes, PAS 1192 is actually a set of standards, if you're not aware, that have been mandated by the UK government for BIM, for all types of infrastructure, and actually by the end of this year will become an ISO standard. And they too wanted to hand over all the construction, all the information created through design and construction to their operations arm, so that that could be used to run their infrastructure more effectively. Now, I could have a go at explaining it to you, but we created a really nice video with Microsoft and with MRT's help earlier this year. And so I will give you a rest from my voice for a little while and show you a short video. So that was a little bit of promotional, and I apologize for that, but hopefully you got a feel for the complexity, for the number of different players involved in that project and how they needed to communicate, and how they're doing that through a connected data environment, or a CDE. So the next thing I thought I ought to try and explain to you is what on earth a CDE is and what does it do for you. Well, I'm a simple man, and so I thought, let's go simple. Connected data environment involves digital context and digital components, and those are glued together by the workflows and the processes and the standards that we use. And what they enable you to do is create what we call digital twins, a direct digital copy of the physical asset that you're designing, constructing, and then in an operating environment, you're operating and maintaining and trying to increase the performance for. And so that CDE connects all the information and all the people that are involved in that infrastructure asset, whatever it might be, and enables them to work more effectively together. Stefan spoke briefly about iModels. iModels is like the currency, is like a currency for communication within the project. Between the different players, between the different offices in a project team, and between the different individuals involved in that. And through that information, we can gain both the ability to collaborate more effectively, particularly through project delivery, but also in handover of that information into operations. And we can gain more insight. We can gain value from the information to enable us to make better and more informed decisions. There's a lot of technology behind it, and I'll cover that in a little bit more detail in the context of both road and rail. So for the final 2/3 of my presentation, I wanted to talk about our road solution and our rail solution, and how that hopefully can help you deliver improved outcomes for your projects and infrastructure in the future. And we'll start with roads. We have a design brand, a set of design products called Open Roads, which allow you to go from what we call conception, the ideas, the first principles of a design, through to construction and handover of that information into operations. So it goes through design, build, and operate. Now, of course, there's not many brand new roads that go from nowhere to nowhere. They're always connected to an existing asset. So I'm going to start in an operational environment. And you might have an existing database of your road network that you're managing in the CDE. And we have applications that allow you to manage change across that network, to improve the reliability of that network. And as you saw, we've got analytics tools that allow you to look at the different performance characteristics. And in future, as we move into as we move further into a big data world, look at information from things like sensors that are built into the infrastructure to be able to make improved decisions. What does that look like? Well, this is a linear reference model network of a set of roadways, and we are basically looking at a a project that we're going to upgrade this road between two existing ones on our map there. We can create the road within this network model. We can assign various bits of metadata to that road. We can say what it's called, what class of road it is, perhaps which direction it's moving in, the class and types of vehicles that might use it. But we can also use that to reference inspection records against. Now, Stefan mentioned context capture, and we saw a city model. This is context capture from a mobile. So the inspector has taken lots of pictures of a fault in that bridge and created, using context capture, a 3D model that then can be attached to that network as a record of the fault or the condition of that infrastructure. And you can do things like change the different layers that you're looking at. You can measure it. You can interrogate that 3D model and look at it in relation to a set of maintenance plans, for example, within the AssetWise solution. So that's just context capture. And a reality mesh is a 3D model built from photographs. I'm going to move into design now. And I mentioned that Open Roads is a set of products ranging from conceptual design with Concept Station. We've got GINT, which looks at the geotechnical information, the subsurface information. Our most recent acquisitions, Stefan mentioned Synchro. We've just bought two companies called Soil Vision, and I've forgotten the other one now. I've started to say there's two. Soil Vision and Plaxis, which are companies that you might have heard of. They're now Bentley products, and so that strengthens our subsurface engineering capability in support of the design work that we do above the surface. Designer looks at the detailed design of our roadways, bridge modelling, moving forward, and Luminar T for visualization, and I'll show you all of these in a little bit of detail. So first we'll start off with looking at a reality model, looking at the contextual information of the scheme that we're working on. And here you can see we can navigate throughout that model in Concept Station. We can actually extract the part of the model that we want to work with. So you might want to, you may have flown a 15-kilometre square area of land, but actually the corridor that you're interested in is much shorter and smaller than that. So you can extract that and use that as the basis of your design work very, very easily. And then when you're working in a sort of conceptual at a conceptual stage, you're going to want to just sketch out different designs and different ideas, and Concept Station allows you to do that. So any moment now you'll see the ability to create new roadways, maybe link existing roads to your design. In this case, we're changing an earthworks section along that roadway into a bridge, and you can see that it's in both 2D and in 3D. And just by striking the line across there and then rotating the view, you can see that we've created a bridge through there. And that information can be taken onwards into the detailed design phase. So all of the work that you do at that conceptual stage is not wasted. It's time that is well spent, and you can reuse that. I mentioned the ability to link the roads, but we can also very quickly and dynamically design things like roundabouts inside Concept Station. And all I'm hoping to do here is give you a feel for how interactive Concept Station is, how dynamic it is, and how it can speed up that process. The other part of Concept Station is at any point in time, you can click a button and you can understand the financial implications of those decisions that you're making. You can get costings and quantities from that project as well. And I'll show you a little bit more of that when we get to rail. Now, moving to China, this is an organization called CCC First Highway. They had a huge project in the one of the southern provinces of China. They had a lot of subsurface engineering to model, over 3,500 underground utilities, 8 major interchanges, and they had just 9 months to do that. And they used Concept Station to achieve that. And the reason I wanted to show you this video is it shows you our clash detection capability subsurface. There in red you saw a duct that was running and interacting or breaking through the underground infrastructure, and they were able to use Navigator to be able to resolve those clashes on the design stage instead of when they get out on site. It's allowing them to reduce the amount of rework, optimize both the information and the quality of the product that they're delivering as well. Let's move into visualization. I mentioned LumenRT. LumenRT came from the movie business and is involved in all the Hollywood movies that you'll remember over the last few years, including things like Avatar, for example. But it puts it in an engineering context, allowing you to take your design models, your conceptual design models, and create really lifelike visualizations and simulations, including, by the way, the ability to link to products like Vissim and bring real traffic models into your road environment and onwards into things like VR, either using things like the Google Cardboard or indeed the higher end, higher quality Oculus Rift and other quality brands of VR headgear are available. And there you see working in a VR environment, jumping and transporting, I think is the word they use, to different parts of that model or simulation. I'm going to skip through this video and move onwards into construction, because all of that information can then be taken from design through detail into construction, and we can look at automating that process. And we're working with Topcon to optimize that for those that are working within the industry. And you heard Stefan use the word constructioneering. What that really means is we can take that 3D model and digitize that workflow so that we're handing that to the machinery and it is using it, not just for things like grading and earthworks, but also, as you see here on the screen, actually laying the asphalt for the road. So it is controlling the level of the blades left and right to be able to ensure that the right quantities of material are laid as per the design, and therefore optimizing the cost of the material that you're using. And of course you can then survey that road as you go and then compare the as-built directly to the as-designed and see where the discrepancies are and see if they're acceptable. So just another way that we're digitizing those workflows. Once it's built, the longest part of your asset's life begins. The operational life of your asset begins. And so that should never be forgotten. But what I wanted to do was go back to where we started and look at how your new design can then be incorporated and go full circle back into your operational database, into your connected data environment for this road network. And you're saying, right, at this point in time, we're going to bring that new design and make that the current model. And you can see that we can update the network model for that particular piece of infrastructure and that intersection right there in the middle of the screen. So open roads and asset-wise leverage information that is sat within your connected data environment. Use those components, context, and workflows that I spoke of. What does that enable you to do? Well, actually, it allows you to link every one of the disciplines, all of the data that they're using, and all of the different applications, be they Bentley applications or, as we saw on the screen, other applications that might exist throughout your organization or the project. Bring those together to be able to streamline project delivery, enable that digital construction, and increase asset performance at the end of the day. Drive more value out of the assets that you're designing, building, and operating. And I mentioned Open Roads and AssetWise are the two brands and sets of products that are used in that operational environment. So I think I'll take questions on both road and rail at the end, but in order to keep to my time schedule, I'm going to move straight on into rail and give you a similar presentation on rail. And then if you've got some really hard questions, then Stefan is still here to answer those, or I'll give them a go myself. Railways are complex. I don't need to tell you that. This is just a few photographs from Singapore, where we gathered last year for our annual user conference, which is in London in 3 or 4 weeks' time. They're complex because they have civils, they have power, they have structural, they have tunnelling. All manner of engineering is involved in a railway. I don't think in infrastructure there is as complex asset type as there is in rail. And in fact, if you just take this slice through, actually it's a station of Crossrail, which is a new rail link being built across, or under in fact, London presently. You can see the number of different types of engineers and disciplines involved, not only in designing and building that asset, but when it becomes operational, maintaining that asset safely and reliably, whilst you've got members of the public roaming all over your railway station, or through your buildings, or across your roadways. Hugely complex, and when you're working in a tunnel like this, in a very tight and confined area. Now, of course, railways aren't the only complex industry in the world. If you think about space, if you think about aerospace, or you think about defence, or some areas of manufacturing, these are very complex industry with lots of different moving parts and different suppliers within the chain that is creating that. And what they use, and what Mark will talk about in more detail, is an approach called systems engineering. And at the heart of systems engineering is what we call a V diagram. I mentioned at the start, I'm a simple man. To me, what this means is that what you conceived at the start, systems engineering is a way of ensuring that that's what you get at the end. What you designed, what you've built, always follows those requirements that were set right at the outset. So as we move down through requirements capture, through specification, and into preliminary design and detailed design, there's lots of checks and balances in place to ensure that you're meeting all of the different standards that are involved. Then we go through building it, and then testing the systems and subsystems in a railway particularly, check that they first work and they work together, and then making sure that that information is handed over in a safe and reliable format to the operator that will continue to run that asset whilst it's in service. And systems engineering is the way that we will go through, if you like, our rail solution, which is called Open Rail. So I'm going to leave that V diagram at the top there, almost as like a map for the journey that we're going to take through rail. Again, it relies on that CDE. This time it's an Open Rail CDE. And that compliance and assurance layer, the systems engineering approach, using a product called ComplyPro, which Mark will cover in more detail after my presentation, is the way that we manage that. And that sits outside your CDE, but uses all the value and the knowledge and the information that sits in there to be able to ensure that you're delivering it as required. Open Rail connects all of the different people involved, all of their data and the disciplines, be they track designers or civil engineers or structural engineers, all of the information and the applications that they use. And I'm going to start in an operational environment again. And using Open Rail operational analytics, we can look at data in a different way and make decisions on that data to help our design project of the future. In this case, we've got quality of the track, we've got geometry, and we're looking at whether we can reuse a length of track if we choose to increase the design speed. And running analytics in the background inside Open Rail Analytics, we get this color map. Green is good, red and brown is not so good. And you see, you click on that and you get a report back that says, at this point, there's insufficient cant deficiency. So we'd have to adjust the geometry. As we click on, it says our transition is too short. And that's information, that's insight gleaned from your CDE that can be used to improve your design planning and your design. It was just the end of the video. I thought the battery had gone then. So that's all insight that you can use to better equip your engineers and your designers with the decisions that they have to make later in the process. So let's move into conceptual design and use this product called Concept Station. And I said I'd show you a little bit more of Concept Station. Here we've got a reality mesh of a piece of downtown. It's actually Oakland in California, and we can see a reality mesh that includes a railway running through it. And we're just going to look at sketching out a new railway. It's quite interactive. Even I can use it, even though my engineering days are a long way behind me. It's very dynamic, so you can rapidly explore different design options. You can drag and drop the intersection points, you can adjust the radius. It's in 3D from the word go. So you can also do things like bring a station in. That station might have been designed in another piece of software, or it might have been designed in Station Designer, which I'll talk about in a few moments' time. But it means that in a single environment, you can match your engineering to your architectural information, and in this case, match the vertical geometry of your new railway line to the elevated platform at this particular station. Now it's sat on an embankment. That's not very good, so let's change that to a bridge. So we can dynamically edit the asset types. We can add bridges with the columns and the piers and the wing walls. We can adjust those dynamically. And you see as we rotate into 3D here, you can see that's been created. Now, we're building this new railway over an existing road, so we can model existing infrastructure as well and measure clearances to it, for example. So we can say, right, we need at least 6 meters clearance between that bridge and the roadway. Very dynamic. It shows you in red that we haven't met that clearance, and when we adjust the vertical geometry, turns to green, and we're good to go. We might want to shift the position of those columns or those piers, and we can do that very dynamically and interactively. So let's just say we've got our new rail bed and track laid. We might now want to actually add the overhead line. So we can model, again in conceptual terms, our overhead line and strike that across our railway. And as we rotate, hopefully you can see it repeated on the screen there. You can see that we've got our masts and our wires in there. We can change the column types. We can change the hangers that the wires are strung from. Things like height and stagger included. We can place signals, or we can place linear infrastructure along that design. Things like safety barriers, or in a road scenario, there might be the Armco that goes along the side of a motorway or splits a motorway or an autoroute. And as I mentioned, at any point in time, we can click on a little button in the software and get financial information at any point. And if this video finishes with doing just that, we can export that to Excel, and that can be used in conjunction with any other costing application that you're using, or indeed produce different deliverables to visualize that project moving forward. So that was Open Rail Concept Station. And all that information that we created can be reused as we move into detailed design. And earlier this year, we released a product called Open Rail Designer, which is the successor to a very well-used, a very popular rail design product from Bentley called Power, or Bentley Rail Track. What that enables you to do is either design or use geometry that's come from concept station, or as we're seeing here, use surveyed information and what we call regress the geometry. Look at how our straights, our transitions, our curves are formed, and then automatically regenerate that as design geometry that we will base our future design on. And we've got tools in there that will allow you to link that that track up, and we can report the coordinates, for example, and all of the geometry that exists, the straights, the arcs that exist along there. We can also place things like turnouts, our switches and our crossings very dynamically and interactively. And this is just a very quick example of how we're using a switch from one of the many international libraries that we support in Open Rail Designer to design a switch and a parallel piece of track and then link those dynamically in the system. Now, of course, we're working not just in 2D, but we're working in 3D. So here we're looking at the creation of a siding or a marshalling yard in 3 dimensions. We've got our centre line, and we're going to hang the corridor off that and then link the 2 railway lines together, in this case just with the ballast that goes across and sits on that formation layer there. So it's very interactive, very quick. But also it models what we call design intent. Our siding is actually related to the centre line of the railway that runs parallel with it. So if we adjust that railway, it will ripple through the design changes to our sidings and any piece of infrastructure that is based on that. And that design change happens quite quickly. We can also bring bridge models in and integrate all of the different disciplines. You see there, again, we're bringing that station model directly into our engineering design environment, which is pretty unique to Bentley. There are ways of doing it in other pieces of software that are on the market, but the ability to bring it into one environment and work with those different data types, those different disciplines together, is pretty unique to Bentley. And again, those design changes roll through and update your drawings, your plans, your profile sets, and visualizations, which we won't repeat. So I mentioned stations. I think stations are often the most public part of a new rail project. They're the focus for members of the public and the politicians, actually. And so within our Open Rail solution, we will later this year release a product called EcoSim Station Designer. Now, you might already have heard of a product called EcoSim Building Designer, which is a product from Bentley that's been around for a number of years. The difference between the two is that we're optimizing Building Designer for stations and metros, both above and below ground, with a type of infrastructure assets that will exist within a station, and to optimize that process for you. But what it does is allow you to bring all of those disciplines together. Here we've got our bridge information, we've got overhead line alongside our station model, our design model. And we've got the context model and actually a plan layout design of the surrounds of that particular station. Because often with a new railway, you're going to have to adjust the road infrastructure and the surrounding infrastructure as well. So we can bring all that together and model and analyze, and as it says there on the screen, visualize how that information looks. There's a computational geometry engine inside EcoSim Station Designer that allows you to model any size or complexity. There we were just doing a simple elevated or elevation of the roof there. But here you can see the same tools used for tunneling and looking at the number of different types of rings used and on that stretch of tunnel. We can look at construction work packaging. We mentioned Synchro. This exists today, and as we move forward, you'll see these come together with Synchro. But we can schedule and simulate and sequence the construction of either a building, as you see here in this example, or indeed the civils works and the track works on your railway. BIM review. Stefan showed this. This is Navigator. Pretty extreme example of a problem gone wrong in our project, I know, but to demonstrate a point, here we've got our roof canopy that is being intersected by an overhead line structure. And so we can redline that model. We can create an eye model of it and send it to perhaps a different organization that might be looking at the overhead line engineering, the catenary, and say there's a problem here, this needs sorting out. And we can track that change and that requirement through our CDE. And Navigator, either on a desktop or on mobile technology, allows us to do that and send the changes or the requirements back to our CDE. Ultimately, it's about building your asset right first time. If you have to do it twice, 3 times, 4 times, it costs you more, and you might overrun on time or your budget. So it's about getting it right first time, all of what we've been talking about. And ultimately, being able to hand over a compliant asset to the owner or the operator of that railway, in this case, in the future. And you'll hear from Mark, as I say, following me, on exactly how we can help you enable that to happen from a compliance side of things. But Open Rail here allows that through the design of your different asset types. There are many, many other products within Open Rail that I haven't been able to touch on today. I mentioned Plaxis, looking at the interaction between underground station structures and soil, for example. There's communications and power and signalling. We can have a product that allows you to do that in Promise E. We have structural modelling capability, all working within that connected data environment and the same modelling environment so that you can bring those disciplines together. Now, one project, big project, that is due for completion any month now. In fact, you might even have read in the papers that it was due for completion later this year, is Crossrail. And it's about 100 kilometres of railway running east-west across London. And it is publicly funded, so the press and the politicians have really got their eye on the project, and it needed to be delivered on time and within the original cost estimates that were outlined. Because of the scale of the project, they had a hugely complex supply chain. In fact, pretty much every one of the major design consultants in the UK was involved in Crossrail in some way, shape or another during its detailed design phase. Big, big project. And they had a huge challenge on their hands. They had to deliver this project effectively, as I say, using all of the different environmental standards, design standards that we're held to. And if you remember when I spoke about CDEs, the CDE, I talked about digital twins, both the project digital twin and the operational digital twin. And Crossrail talk about delivering 2 railways, a physical railway that will run into the future, but also a digital version of that railway. And you see just an example that I came up with here, where we've got the design model that is visualized inside MicroStation and driven down using an animator, I think it's Navigator actually. And on the left-hand side, you can see a video that Crossrail themselves created, flying a drone down the infrastructure as it's being constructed. And each of them is kept in sync through a connected data environment that back in 2016, up to 2016 was running on-premise, but then they moved into the cloud using the Azure platform. And that's been running there ever since without any downtime and providing them with the information that they need to design, construct, and ultimately that information will be handed over to a company called Rail for London, who have the license to operate that infrastructure into the future. So final video from me, back into an operational environment. Here we've got condition information, we've got geometry information, we've also got work records of of actual maintenance that has happened on that track. And using analytics tools, we can look at trending of information. When, at what point in time, is that length of track going to be in a condition where I'm not going to be able to use it safely at the right speed? Or in this example, we're looking at the data that's come from a sensor sat on a switch, and it has reported that the start and end time from moving from one point to another has increased dramatically, and the amount of power it's using has increased dramatically. We can see all the warnings, we can see the failure modes inside the solution. Look at maintenance records. In fact, I think there you can see that, yep, it was lubricated and a couple of times, but we still got the same problem. So actually changing the belt on this switch is the required maintenance scenario in this example. So from here, in order to run it safely and achieve the compliance that we need, we can create the works order and we can actually send that out to, for example, Maximo that you might be using to operate and maintain that railway, set a timeline for solving that problem and moving forward. And we can bring all that information together in something that a colleague of mine actually defined or named a war room. All it is connecting the different data types together. Here we've got a reality model with our design model. Here we've got bridge inspection information. Over here might be a GIS or a mapping. And at the top, we've got our operational analytics, all connected so that if you make a move and a change in one, you see that change reflected and that interrogation reflected in all of the different other views. Ultimately, it's about delivering and maximising the safety and reliability of your railway in the future. And that's really what OpenRail is targeted on. It and roads is based on that CDE, the components, the context, the workflows that allow you to join everything together, to connect everything together, deliver the required compliance and assurance, streamline both the delivery of your new project. It might be a project that's on an existing railway, by the way. It might be a large-scale upgrade. It doesn't have to be a brand new railway, but streamlining that delivery of the project, increasing the performance of the asset, and ultimately, we think that OpenRail has the potential to transform the way that rail and transit is both designed, constructed and operated in the future. Or as we say there, transforming rail and transit from planning through performance. And that's really it from me. I'll leave you with that final slide and I'll take any questions. But this is just a picture of just some of the rail projects that we've been involved in around the world. Let's go back to that. From the US to Crossrail in the UK, to projects throughout Europe, through the Middle East, onwards into Asia and China with bridges and new metros. It's about delivering different outcomes. Thank you.